Okay, Unit 8 Test Study Guide, question number 23. A married couple decides to have 4 children. What's the probability of each of these options occurring? Again, a Punnett square works well if we have just 2 events. This is 4 events because it's having 4 children. You're going to need to make a tree diagram. These take up a lot of space, so give yourself plenty of room. The first child could either be a boy or a girl, and I'm spreading them way out so that I give myself plenty of room to branch out. The second child, after having a boy, you could have a boy, you could have a girl. After having a girl, for the second child, you could have a boy or you could have a girl. Third child, branch off again, give yourself plenty of room. Boy or a girl branches off of each one of these. After having a boy, then a girl, you could have a boy or a girl for the third child. After having a girl and then a boy, you could have a boy or a girl for the third child. Same thing down here, a boy or a girl. That's 3 children. We still have to have a 4th, so we're going to branch one more time. And boy, girl, boy, girl. And this is where you end up needing the space that you tried to give yourself at the start. Boy, girl off of each one of these. And then the important thing is take it that last step and make the list of possible outcomes. This would be, and you just follow the branches across. To get to here, you'd have had 4 boys. Here you would have had 3 boys, and then the last child being a girl. This one would be boy, boy, girl, boy. And then this one, boy, boy, girl. Whoops, girl. Red, really? Girl. And then boy, girl, boy, 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 girl, boy, girl. I have to follow my branches. I almost went one line too far. Boy, girl, girl, boy, and boy, girl, girl, girl. That's all of them with the first child being a boy. Now the first child will be a girl, and then we could have all boys. We could have erasable pens are wonderful. Girl, boy, boy, girl, girl, boy, girl, boy, girl, boy, girl, 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 boy, boy, girl, girl, boy, girl, 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 boy, and finally all girls. Okay, that's the whole tree for 4 children. 2 options here, 2 options here, 2 options here, 2 options here. Multiply together those options. 2 times 2 is 4, times 2 is 8, times 2. There are 16 outcomes. 2, 4, 6, 8, 10, 12, 14, 16 outcomes. The probability of having all girls, that only happens down here at this bottom row. That is 1 out of 16 possible outcomes. 2 boys, you have to go through the list. And now this is only 2 boys, so we're looking for ones that have just 2 boys. This is the first one. That was 4, 3, 3. That was 2 boys. I missed it because of my poor handwriting. And here was 2 boys. Here's 3 boys. Here's another one with 2 boys. Here's another one with 2 boys. Here's another with 2 boys. And that looks like it. 1, 2, 3, 4, 5, 6. 6 out of 16. Reduce your fraction. Those are both divisible by 2. Divide by 2. 6 divided by 2 is 3. 16 divided by 2 is 8. 3/8. Okay, 3/8 probability of having 2 boys. At least 2 boys. That would mean 2 boys or more. So it would be all of these that we've already marked with 2, plus any that have 3 or even 4 boys would be at least 2 boys. So this is another, this is another, this is another, this is another. This one we only have 1 boy. Here is 3 boys. Okay. And that looks like it. So 2, 4, 6, 8, 10, 11. 11 of them would have 3 boys. 11/16. And I'm going to check the answer key before I shut this down to see that that is correct. And that is it. It's 11 out of 16. Making sure I didn't miss any. So that is it. You really need the tree diagram. You really need that list at the end in order to find all of those options that give you 3 boys. In class I may talk to you about a different way, but definitely the tree diagram with the list is a good way to get this.